Okay, so let's see how you find the formula mass. Now, for example, if you need to find the mass of carbon dioxide, formula mass is the sum of all the mass of all the atoms in a compound. So how many atoms are there in carbon dioxide? It's mass of carbon plus 2 times the mass of oxygen. So there's double oxygen. So you look at the periodic table, the atomic mass of carbon is 12, oxygen is 16. So 16 times 2 is 32 plus 12 is 44 grams. If you're given calcium carbonate, CaCO3, so that is mass of calcium plus mass of carbon plus 3 times the mass of oxygen, which is 100 grams. Okay, now let's look at a complex molecule like CaPO4 Now, what is the indication of this 3 is that anything which is inside the bracket should be times by 3. So the mass of phosphorus should be times by 3, and oxygen, which is already 4, that is oxygen mass times by 4 and then times it by 3. That is 12 times the mass of oxygen. So for calcium phosphate, the mass will be mass of carbon plus 3 times the mass of phosphorus plus 12 times the mass of oxygen. If you put this masses, you'll get 310 grams. Okay, so now you should know the definitions of relative formula mass and atomic mass. So relative formula mass is the sum of relative atomic mass of all the atoms present in a compound, and the atomic mass is the ratio of the average mass of one atom compared to the 1/12 of the mass of carbon-12. Okay, so make sure you remember this definition. Now let's come to the moles triangle. So I have made these triangles, okay, and these triangles are very, very important. Okay, make sure you understand these triangles. If you want, you can make these triangles, stick it to your study table so that you can see and revise them every day. So the first is how you convert the mass into moles. Now to convert the mass into moles, you divide the mass with the MR, the atomic mass, or if it's a formula compound, you divide it by the formula mass. So moles is mass over an MR. Okay. If you have the volume at the standard room temperature pressure, and if the volume is in decimeter cube, you can divide it by 24 to find the moles of the substance. Okay. Similarly, if you have the concentration, you can find it by moles divided by volume, provided volume has to be in dm cube. So this is the moles in the mass triangle, this is the moles in the volume triangle, and this is the moles and the concentration triangle. Okay, now in most of the cases they give you the volumes in centimeter cube. You must have seen in many questions in your textbook. So you should know how to convert the centimeter cube to decimeter cube. So centimeter cube is converted to decimeter cube by dividing it by 1000, and decimeter cube can be converted into centimeter cube by 1000. Okay, so they can give you any volumes, any masses, any concentration, and can ask you to find the moles. So these triangles will be very helpful. So what is moles? Moles is nothing but the amount of substance. Okay, and 1 mole can also tell you that how many atoms or molecules are present, because 1 mole is equal to the Avogadro's constant, which is 6.02 times 10 to the power 23 atoms or molecules. So if they ask you to find in the exam the number of atoms or molecules, you convert that value into the moles by using any of these 3 triangles, and then you times it by the Avogadro's constant, 6.02 times 10 power 23 atoms. Okay, now let us look at few examples. The first question is, calculate the moles of 22 grams of carbon dioxide. Now from the triangles you can see that moles is mass over an MR, so 22 divided by 54 is 0.5 moles. 17 grams of ammonia. MR of ammonia is nitrogen plus 3 hydrogen, which is 17. So you have 17 grams of ammonia. So we will do 17 divided by 17, and you will get the answer as 1 mole. 48 decimeter cube of oxygen. To find the For 48 decimeter cube of oxygen, if you remember, volume divided by 24 is moles. So 48 divided by 24 is 2 moles. For 24,000 centimeter cube of carbon dioxide, remember, you need to convert it into dm cube. So divide by 1000, that gives you 24 dm cube. And moles is the volume divided by 24, so that is 1 mole. Next is 20 grams of sodium hydroxide dissolved in 50 centimeter cube of solution. Moles is, you need to divide the 20 grams by the MR, which is 40. That gives you 0.5 moles. Okay, so I hope you are now able to find the moles by different ways, whether the volume is given or the mass is given. Now let's look at how you can use the moles to find the mass. So we will use the same triangles. if you have the moles, you can times the moles by the MR to find the mass. So if there's 2 moles of calcium carbonate is CaCO3. So the MR of CaCO3 is 100. So 2 times 100, 200 grams will be the mass of 2 moles of calcium carbonate. 0.1 moles of hydrochloric acid, MR of hydrochloric acid is 36.5 times by 0.1. That will give you 3.65 grams. Next is 2 moles of sodium hydroxide dissolved in 10 decimeter cube of solution. Concentration is moles divided by volume. Remember, volume has to be in dm cube. So 2 divided by 10 is 0.2 moles per dm cube. 20 gram of sodium hydroxide dissolved in 50 centimeter cube. You need to first convert 20 grams into moles, which is 0.5. The volume, you have to convert it into decimeter cube by dividing it by 1000. So that is 0.05 decimeter cube. And then you can do moles divided by volume. So 0.5 divided by 0.05 gives you 10 moles per dm cube as in concentration. Okay, so I hope the use of triangle is clear to you. Now let's see how we can use the Avogadro's constants and connect them all. The next question says, calculate the number of molecules in 49 grams of sulfuric acid. Now we know the MR of sulfuric acid is 98. The moles which are there in 49 grams is 0.5 moles. We will times it by the Avogadro's constant, 6.02 times 10 power 23. And we will get 3.01 times 10 to the power 23 atoms of sulfuric acid. Next question, 8 grams of oxygen. We'll divide it by the MR, which is 32, and get 0.25 moles, times it by the Avogadro's constant, and we'll get the answer 1.5 times 10 power 23 atoms. 48 decimeter cube of nitrogen divided by 24, we'll get 2 moles, times it by 6.02 times 10 power 23, and we'll get 1.2 times 10 power 24 atoms. 50 centimeter cube of 0.1 moles per dm cube of sodium hydroxide. Moles is concentration times the volume. The concentration is 0.1, volume is 50 over 1000 because it is in centimeter cube. That gives us 5 times 10 power minus 3 moles. We'll times it by the Avogadro's constant and we get 3.01 times 10 power 21 atoms. Okay, so I hope the calculations of moles, the calculations of number of molecules, calculation of masses and volume is clear to you. Okay, now let's see what is a balanced chemical equation. Now there are a lot of questions where you will be asked to find the moles or masses from the balanced chemical equation. For that, it is very important you understand how you balance the equation and what information a balanced chemical equation gives us. So if this is an equation, carbon plus oxygen give carbon dioxide, this equation tells us that 1 mole of carbon is reacting with 1 mole of oxygen, making 1 mole of carbon dioxide. On the other hand, the next equation, Mg plus 2HCl gives MgCl2 plus hydrogen, tells us that 1 mole of magnesium combines with 2 moles of hydrochloric acid to form 1 mole of magnesium chloride and 1 mole of hydrogen. 2 aluminium plus 3 oxygen plus 2 Al2O3 tells us that 2 moles of aluminium combines with 3 moles of oxygen to give 2 moles of aluminium oxide. Okay, now how we will use this balanced chemical equation? If we know the moles of oxygen, we can easily find the moles of aluminium. Or if we know the moles of aluminium, we can easily find the moles of aluminium oxide. Because according to this, the moles of aluminium and aluminium oxides are same, 2:2, that is 1:1 ratio. So if in a reaction, 5 moles of aluminium is reacted, how many moles of aluminium oxide will be formed? 5 moles. Okay, so the balanced chemical equation gives us the ratio of the moles of each and every element that is reacting. Okay, now let's see how you need to do the calculations from equations. Now, in the exam, they'll give you a balanced chemical equation. In the balanced chemical equation, they'll give you the mass of any one reactant, and they'll ask you to find the mass of the product formed, or they'll give you mass of the any product. You have to find the mass of the reactant formed for that given mass. Now, how will you do that question? So here I have given up the steps to do this question. I'll go over the step one by one. Make sure you understand it. Okay. So the first step is you always write the balanced chemical equation. So this is a reaction where there's a magnesium and oxygen reacting to form magnesium oxide. So I'll write the balanced chemical equation. 2Mg plus O2 gives 2MgO. So that is the first step. Step 2 is what information is given to you in the exam, in the question, you put it to the left, and what they ask you to find, you put it to the right. So in this question, if you read it, calculate the mass of magnesium oxide produced when 6 grams of magnesium burns. They have given you the mass of magnesium and they have asked you to find the mass of magnesium oxide. So the known I have put to the left of the equal to sign, and the one I have to find I have put to the right of the equal to sign. So that's my step 2. Step 3 is write the relationship between the two from the balanced chemical equation. So from the balanced chemical equation, how many moles of magnesium is reacting? 2. How many moles of magnesium oxide is formed? 2. So underneath each, I'll write 2 moles and 2 moles. Next step is convert these moles into masses. So 2 moles of magnesium will be times it by the MR, 48 grams. 2 moles of magnesium would be 2 times the MR of MgO, which is 80 grams. So now I got the mass relationship between the two, that if there's a 48 grams of magnesium, the MgO form will be 80 Mg. Now I can do the maths. Now what is the maths? 48 grams of Mg gives 80 grams. 1 gram will be, I'll divide by 48. So I'll divide by 48 the other side. So 80 divided by 48. Now they have given me 6 grams of magnesium. So from 1 to 6, I'll times by 6. I'll times by 6 on the other side. So 80 divided by 48 times by 6 give me the answer of 10 grams. It means 10 grams of magnesium oxide is formed when 6 grams of magnesium react. This is the way you have to do this question. I'll again take you through the step. Write the balanced chemical equation, put known to the left, unknown to the right, write the first relationship of moles from the balanced chemical equation, converts the moles into mass, and do the maths. Okay, now let us look at one more example. They say calculate the mass of aluminium needed to produce 306 grams of aluminium oxide. Now first, the balanced chemical equation. Aluminium plus oxygen gives Al2O3. In the exam, they might give you the equation as well. Now, what is known to us? They have given us the mass of aluminium oxide. So I'll keep the mass of aluminium oxide to the left and I'll put aluminium to the right. Then the first relationship of moles will be from the balanced chemical equation. So how many moles of aluminium oxide are being formed? 2. How many moles of aluminiums are being used? 4. So 2 moles and 4 moles. Then I'll convert 2 moles of aluminium oxide into mass. So 2 moles of aluminium oxide is 204 grams. 4 moles of aluminium is 108 grams. So 204 give me 108. How do I get 1 gram? I'll divide by 204 both sides. Then I have to find aluminium oxide is 306. So I'll times it by 306. And this will give me the answer 162 grams. Okay, so I hope how do you calculate from the reacting equations or reacting masses is clear to you. Just follow this step and you will never make an error. Okay, so this is how you do the calculation. Now, remember, this is very important because if you do not understand this, you'll have a problem in finding the percentage yield. Okay, now there's just small concept to see. In an exam, they will give you the mass of both the reactants and they can ask you which one is a limiting reagent. Now, always remember what is a limiting reagent. A limiting reagent is that reactant that is present in the less quantity and that is completely used up in a reaction. Okay, so for example, I say in a reaction, 4 moles of aluminium reacts with 3 moles of oxygen. And suppose I mix 4 moles of aluminium and 4 moles of oxygen. Now, according to the balanced chemical equation, for 4 moles of aluminium, I require 4 moles of oxygen, 3 moles of oxygen. So if 4 moles of oxygen is given to me, it means that my oxygen is in excess. 4 moles of aluminium will completely get reacted with 3 moles of oxygen. So my aluminium in that case will become the limiting reagent and the oxygen is in excess because it is present in the extra quantity than it is required. Now, how do you work out the limiting reagent in every reaction? You first write the balanced chemical equation and find the moles that are reacting and then find the moles which are given to you. And from that, you will work out which is in excess and which is limiting. So, for example, a question says 13.5 grams of aluminium and 32 grams of oxygens are there. Now, you will convert the moles by doing the mass divided by MR. So 13.5 divided by 27 gives 0.5 moles of aluminium and 1 mole of oxygen. Now, if you look at the equation, if you have 4 moles of aluminium, you require 2 moles of if you have 4 moles of aluminium, you require 3 moles of oxygen, right? So 4 moles of aluminium gives you 3 moles of oxygen. If you have 1 mole of aluminium, you require 3/4 of oxygen. But the aluminium is half a mole, so half a mole will be, you need just 0.375 of oxygen. And how much oxygen you have? 1 mole. So the oxygen is in excess and aluminium is a limiting reagent. It will get completely used up. Now, how will you find the mass of aluminium oxide? By doing the calculation in terms of limiting reagent. So you will see the relationship between the limiting reagent and the product. So you will keep the aluminium, the limiting reagent, to the left, aluminium oxide to the right. From the balanced chemical equation, 4 moles of aluminium gives 2 moles of aluminium oxide. 1 mole will give 2/4. Here we have how many moles of aluminium? 0.5. That will give you 0.25 moles of aluminium oxide, and you can times the 0.25 by the MR and you can get 25.5 grams. Okay, so I hope this calculations of limiting reagent is clear to you. This is important. You should know the definition of limiting reagent and how do you work out the limiting reagent. Now let us move on to the percentage yield. Now, whatever we have done so far is the theoretical calculation that by theory, if we are mixing this much amount of reactants, we should get this much grams of products. But that does not happen in reality. In reality, you always get lesser than what you expect or what you calculate from theory. Okay, and the ratio of the observed mass over the expected mass gives you the percentage yield. So percentage yield is given by the formula observed mass over the expected mass times by 100, or you can write it as actual yield over theoretical times 100. Now, how do you work out the theoretical yield? It's the same process we just did just now. How do you do the calculations from an equation? So for example, a question is given to you that when 28 grams of nitrogen reacts, 30 grams of ammonia is made. Calculate the percentage yield. So first we'll calculate theoretically that when 28 grams of nitrogen is reacting, how much ammonia is formed. So we'll do the same stage. Write the balanced chemical equation. Known to the left, nitrogen, ammonia to the right. Nitrogen from the balanced equation is 1 mole, ammonia is 2 mole. Convert this into masses. So 28 grams is 34 grams. So with 28 grams of nitrogen, we should get 34 grams of ammonia. But how much we are getting? We are getting 30 grams. So expected is 34, but observed is 30. So percentage yield is 30 over 34 times by 100, which is 88.2%. Okay. Now let's take another example. When 80 grams of iron oxide reacts with carbon, according to this equation, 20 grams of iron is produced. So we'll keep iron to the left, iron oxide to the iron to the right, iron oxide to the left. From the balanced chemical equation, 2 moles of iron oxide is forming 4 moles of iron. We convert it into mass. 320 grams of iron oxide is 224 grams of iron. We'll find the mass of 1, divide by 320, and then we'll times it by 80 because iron oxide is given us to be 80. So 224 divided by 320 times by 80 gives us 56 grams. That is, we should get 56 grams of iron when we are having 80 grams of iron oxide. But what we got actual, we got 20 grams. So we'll divide the two. 20 divided by 56 times 100. It means the yield is just 35.71. Okay. So remember, you need to do the theoretical calculations, find out what you should get as per the calculation. What you observed, you divide the two and times it by 100, and that gives you the percentage yield. Now, the next question is, why the percentage yield is not 100%? They can ask you this question. So you should know what are the various reasons why the yield always decreases. The percentage yield can never be greater than 100, and it is difficult to get the 100% yield. Now, why the yield is not 100%? First, maybe certain reactions do not go to completion and the products are not formed. Some of the reaction, if they're reversible, can start moving to the reverse side. So that will also decrease the yields. Some of the reaction can go and form the alternative or the unwanted product. So might not make the product that you want. During the reaction, if it involves mixing, some of the reactant can just stick to the vessel and do not react. Or some of the reactants, if they are gases, can be lost. Some of the products can also be lost in the reaction vessel if it involves the gas, or maybe the reactant is not pure, therefore it did not react completely. So you should remember these reasons, because in the exam they can ask you to find the percentage yield and then ask you to give the reason why it is not 100%. And always remember, the scientists are always try to devise that rule which gives the maximum percentage yield. Now, there's another concept which is very important for the chemist, is the atom economy. Atom economy is what is the MR of the desired product over the total MR of all the reactants times by 100. Okay, now let's see how this works. Calcium carbonate gives calcium oxide plus carbon dioxide. What is our desired product? Calcium oxide. What is the MR of that? 56. What is the mass of the reactant? There is 100 grams of the reactant that is reacting. So atom economy is 56 over 100 times 100. So it is 56%. Let's take another example. Fe2O3 plus 3 carbon give 2 Fe plus 3 CO, and desired product is iron. So what is the mass of the desired product? 2 times the MR of iron, which is 112 gram. What is the mass of all the reactants? So that is the mass of Fe2O3 plus 3 times the mass of carbon. So once we do that, we get the percentage yield as 112 over 196 times by 100. That gives us the atom economy. So this is the atom economy to be 57%. Okay, so I hope this concept of finding the atom economy is clear to you. Now, there are some reactions which have 100% atom economy. These are those reactions which produces only one product. And what are those reactions that produces only one product? These are addition reactions. So how can the scientists increase the atom economy? They can look for those reactions that produces a single product and go for the addition reaction. And if there are any reaction that is producing any byproduct, it is better to recycle it or use it in some other reaction to increase the atom economy. Okay, so I hope the atom economy and the percentage yield is clear to you. Now let us look at the last concept you need to do, is the titration. Now this titration you all must have done in your class practical, in your school practical. You should first know the apparatus. In the exam they can give you the apparatus and ask you to label it with its function. So this is a conical flask, and in the conical flask you put any solution for which you know the concentration, and you put the required volume, and you also know the volume of this solution. And how do you find the volume of, how do you measure the volume of this solution? With the pipette. So with the pipette, pipette is a tube which has a bulb in the middle. You suck out the required volume, put it into the conical flask, and in the conical flask only that solution goes for which you know the concentration. Okay, then into the conical flask you add an indicator. Indicator is used to determine the endpoint. Endpoint is when acid and alkali has completely reacted. Titration is a technique which is used to determine the exact volume of the acids and the base to carry out a neutralization reaction. In a burette, you fill that quantity for which you do not know the concentration. So you find out the volume that is completely neutralizing the conical flask contents with the help of the burette. So you fill the burette, measure the start volume, then open the tap, allow the contents of the burette to fall into the conical flask. As soon as the indicator changes the color, you stop the tap and note the final volume. So the initial and the final volume difference gives you the titer value, that is the volume of the unknown concentration required to neutralize the known concentration, and from that we do the calculations. So let's understand the process again. So the known concentration solution, which could be either an acid or a base, is measured by the pipette and added to the conical flask. For this solution that is added to the conical flask, both concentration and the volume is known to us. Second, the indicator is also added in the conical flask. When an indicator changes color, the end point is reached. It means that the solution is completely neutralized. The unknown concentration solution is added into the burette. The starting volume is noted from the burette. The tap is then opened and the unknown solution is added dropwise into the conical flask with regular mixing. As soon as the indicator changes color, the tap is closed and the final reading from the burette is used. The entire process is repeated 3 times and the volume are wrote in the following format. So we wrote the experiment number, what is the initial reading of the burette, the final reading, and the titer, which is final minus the initial. The entire process is repeated 3 times and the values are noted into the following format, and we take the concordant reading. Concordant readings are any 2 readings which have a difference of 0.1 or 0.2. Okay, and generally the first reading is not taken into consideration. It's a rough reading. So if we see the start volume we got as 25.7, final at 49.6, we take away the two values and this is what we get the titer. Now how do you find the mean titer? You take the concordant reading, which are 0.1 to 0.2 decimeter in difference, add them up, divide by 3. There are 3 values. If there are 2, add them, divide by 2. So we get the average titer to be 25.29. Okay, so now let's see how do you do the calculations. Now for this, we will take a help of the moles triangle. The concentration is in moles per dm cube and the volume is in decimeter cube. The question here says that 10 centimeter cube of 0.5 moles per dm cube sulfuric acid is titrated with sodium hydroxide. So for sulfuric acid, we need both the volumes and we also need the concentration. Okay, and for the NaOH, we do not know anything. We just find out the volume from the titration. So we did the runs, final volume, initial volume, and we got the mean titer. So how to do the titration questions? I have listed out in easy to follow steps. First, you write the balanced chemical equation. So this is my balanced chemical equation. 2 NaOH plus H2SO4 is 2 give you Na2SO4 plus water. Okay, this is the balanced chemical equation. Now, always remember, either the equation will be given to you. If the equation is not given to you, I recommend you to check the video of C5 chemical changes where I've explained you how to write the acid-base equation. So, NaOH plus sulfuric acid gives Na2SO4 plus water. And the molar ratio is 2:1. That 2 moles of sodium hydroxide gives 1 mole of sulfuric acid. Now, underneath each of them, write the information given to you. So for H2SO4, we have the volume to 10 centimeter cube. And remember, I told you that the centimeter cube needs to be divided by 1000 to get the volume in dm cube. And the concentration is given to you as 0.5. Now, for sulfuric acid, we have 2 values. So the quantity that has 2 values, use the concentration triangle to find the moles. Now, according to the concentration triangle, mole will be concentration times the volume. So we did 0.5 times 0.01. So that gives us 5 times 10 to the power minus 3 moles of sulfuric acid. Then you find the other reagent mole by looking at the balanced chemical equation. Now the balanced chemical equation tells you that 1 mole of sulfuric acid gives 2 moles of NaOH. So whatever moles of sulfuric acid we have, we'll double it to find the moles of NaOH. So if sulfuric acid moles is 5 times 10 to the power minus 3, we times by 2, the moles of NaOH is 10 to the power minus 2 moles. And the volume from the mean titer, we got to have it as 25.29. Okay, now how do you work out the concentration? We'll first take the volume, which is 25.29. We divide it by 1000. So the volume is 0.025 and our moles is 10 to the power minus 2. And we will do 10 to the power minus 2 divided by the volume, and that will give us the concentration. Okay, so what is the moles? Moles is 10 to the power minus 2, and so we'll do 10 to the power minus 2 divided by the volume, which is 0.025, and that will give us 0.4 moles per dm cube as our concentration. Okay, so I hope this example is clear to you. Now let us take another example. So in this question, we'll take the help of our moles triangle, our centimeter cube, decimeter cube conversions, and let us look at the question. So it is of potassium hydroxide combining with sulfuric acid. And remember, when you have KOH combines with H2SO4, you write the balanced chemical equation, and that will give you K2SO4 plus water. Okay, so this is my first step. I have written the balanced chemical equation. Then underneath each, I'll write what values are given to me. So what is the value given to me? That for KOH, my volume is 50 centimeter cube. So which is 50 divided by 1000 to convert it into dm cube. So that is 0.05 dm cube. And the concentration is 0.1 moles per dm cube. And for sulfuric acid, from the titration, they have not given me the table, but this time just told me the volume. So that is 20. So 20 divided by 1000, that gives me the answer as 0.02 dm cube. Now, the quantity, I have more values, I'll times each other to find the moles. So 0.05 times by 0.1 gives me 0.005 moles. Now I got the moles of KOH. Now, what will be the moles of sulfuric acid from the moles of KOH? I need to divide it by 2 because 2:1 is the ratio. Okay, so I'll divide this by 2. So that will give me the moles of H2SO4 as 0.0025 moles. I got the moles, I got the volume. Concentration is moles divided by volume. So I'll divide this by the volume and I'll get the concentration 0.25 moles per dm cube. So I hope this process is clear to you. Write the balanced chemical equation, write the values underneath each for which you have more values, find out the moles of the other by the molar ratio, and then do the concentration calculation according to this triangle. And remember, centimeter cube to dm cube, you need to look at this. Okay, so I hope this titration example is clear to you and all the calculations that we have done in this. Now let us just quickly look over what are the key terms we saw in this unit. What is a relative atomic mass? It is the ratio of the average mass of an atom compared to 1/12 of the mass of carbon-12. Relative formula mass, sum of relative masses of all the atoms present in a formulae. Moles is the amount of substance that has same number of particles found in 12 grams of carbon-12. Avogadro's constant is the number of particles present in 1 mole of the substance, and 1 mole is 6.02 times 10 power 23 atoms. Limiting reagent is a reagent that is completely used up in the reaction. Yield is the mass of the desired product obtained in a chemical reaction. Percentage yield is actual yield over theoretical yield times by 100. Atom economy is mass of desired product over the total mass of all the reactants times by 100. Concentration is the mass of solute. If you have to find in grams per dm cube, it is mass of solute in grams over volume of solution in decimeter cube. What is titration? It is a technique used to determine the exact volume of acids and alkali required to carry out the neutralization reaction. Neutralization reaction is a reaction in which the acid reacts with base to form salt and water. A neutralization reaction in which acid and base react to form salt and water. Acid is substance that has pH less than 7. Alkalis are soluble bases that has pH greater than 7. Pipette is a glass tube with a huge bulb in the middle that is used to take out the exact volume of known concentration solution. Burette is a long tube with a tap at the bottom that is used to measure the titer, and concordance are the values in the difference range 0.1 to 0.2 centimeter cube. Okay, so I hope all these key terms are clear to you. It is important to remember all these key terms with these exact definitions. Okay, now it's the time to test yourself to see if you have understood what we discussed in this. These are the questions given to you. It says calculate the number of moles of the following: 10 grams of calcium carbonate. So let us do this question. So once you are given the 10 grams of calcium carbonate, what is the MR of calcium carbonate? I hope you know to find the MR of calcium carbonate, you do mass of calcium, mass of carbon plus 3 times the mass of oxygen. So that is 100 grams is the MR. So to find the moles, you do 10 divided by 100, and 10 divided by 100 gives you the answer as 0.1 mole. So the answer for the first one has to be 0.1 mole. Then 98 grams of sulfuric acid. The MR of sulfuric acid is H2SO4, which is 2 times the mass of hydrogen, plus sulfur, which is 32, plus 16 times 4. And that will give you 98 grams. So 98 divided by 98 will give the answer 1 mole. 18 grams of glucose. Now what is glucose? Glucose is C6H12O6. So you will do 12 times 6 plus 12 plus 16 times 6. So that will give you the MR as 180. And you do 18 divided by 180. And that will give you the answer as 1/10. So that is 0.1 moles of glucose. Next is 90 centimeter cube of oxygen. So first you will convert 90 centimeter cube into the dm cube. So you will do 90 divided by 1000, which will give you 0.09 dm cube. And then the 0.09 dm cube, you will divide it by 24, because For the moles, you need to divide it by 24 and you will get the answer as 0.00375 moles. Next is 10 centimeter cube of 0.2 moles per dm cube sodium hydroxide solution. Now to find the moles, you do concentration times the volume. Our concentration is 0.2. Our volume is 10, but it is in centimeter cube, so you divide by 1000. So it is 0.2 times by 10 divided by 1000. So it is 0.002 moles. So it is 0.2 times by 10 divided by 1000. Okay, so I hope how to calculate the number of moles is clear to you. Next is calculate the mass of magnesium required to form 160 grams of magnesium oxide. So again, we'll follow the same step. Mg, you need to find out. So we will put Mg to the right like this. And you have been given MgO, we will keep it to the left. We will see the balanced chemical equation. The balanced chemical equation says Mg plus O2 gives 2 MgO. So from the balanced chemical equation, what is the relationship? Relationship is 2 moles of MgO is giving us 2 moles of Mg. So it means 1 mole of MgO is giving us 1 mole of Mg. The mass of 1 mole of MgO is 40 grams and the mass of Mg is 24 grams. So 40 grams of MgO is giving us 24 grams of Mg. So 160 grams will give us 24. So 40 to 160 is times by 4. So we'll times by 4 onto the other side as well. And we will get the answer as 96 grams. Okay. So I hope this question is clear to you. Now let's look at the third question. Hydrogen reacts with chlorine to form hydrogen HCl gas. So let's write the balanced chemical equation. H2 plus Cl2 gives 2 HCl. They say when 71 grams of chlorine react. So the chlorine is given to you, you have to find the mass of HCl. Okay. Now 1 mole of chlorine is giving us 2 moles of HCl. Now what is the mass of 1 mole of chlorine? 1 mole of chlorine is 71 grams. And what will be the mass of 2 moles of hydrogen chloride? So that is 35.1 plus 1 times by 2. So the mass of chlorine is 35.5 plus 1, which is 35.6. So 35.5 plus 1, which is 36.5 times by 2. So we should get 73 grams of hydrogen chloride. But how much hydrogen chloride we are getting? 70 grams. So percentage yield is how much we expected. We expected to be 73. But how much we got? We got just 70. So 70 over 73 times by 100, that will gives us the answer as 95.8% is the percentage yield. Okay, so I hope the percentage yield is now clear to you. Now let's move on to the next question. Calculate the atom economy. The atom economy is the mass of the product take over the mass of all the reactants. Now what is the mass of the product? It is ammonia, which is 2 moles. So that is 17 times 2, which is 34. Okay, and what is the mass of the product? That is 28 plus 6, which is also 34. So 34 over 34 times by 100. This reaction has 100% atom economy, and that makes sense as well because it is making only one product, which is desired. So the percent atom economy has to be 100%. Okay, now what is the calcium carbonate? Our desired product is calcium oxide, and what is the mass of calcium oxide? 40 plus 16, 56 over the mass of the reactant. CaCO3 mass is 100. We times by 100, so 56% is the atom economy of this. Okay, now let's see the last question. It says 50 centimeter cube of 0.2 moles per dm cube of HCl reacts with NaOH. You need to determine the concentration of NaOH. Now remember the steps that I told you. You first write the reaction. So NaOH plus HCl give NaCl plus water. Whatever I have I know I'll write underneath it. So 50 centimeter cube of HCl is given. So volume is 50 centimeter cube. So I'll write 50 divided by 1000, which is 0.05 dm cube. The concentration of HCl is given to me as 0.2 and NaOH volume is given to me as 10 centimeter cube. So 10 divided by 1000 is 0.01 dm cube. Okay, so we have concentration, we have volume, we can find the moles. So we will do 0.05 times by 2, that is 0.1 moles per dm, 0.1 mole. And if you see the balanced chemical equation, the moles of HCl and NaOH are the same. So the moles of this as well is 0.1. So we got the moles, we got the volume. Concentration is moles divided by volume. So 0.1 divided by 0.01 is 10 moles per dm cube will be the concentration of NaOH, which will cause a complete. So let's begin. Now, if you remember from the topic when we were doing metals, we discussed about the reactivity series. So reactivity series is a series where we have the most reactive element at the top and less reactive at the bottom. Now, although there are just metals here, we have two non-metals. You can see we have hydrogen, we have carbon. Now, whenever we react metal with dilute acids, the metal is actually displacing the hydrogen. So all the metals which are above the reactivity series, then the hydrogen will react with dilute acids and they form salt and hydrogen. Similarly with water, all the metals which are above hydrogen will react to form metal hydroxides and hydrogen. And we will see the elements at the top will show the violent reaction. The elements in the middle will show slow and the very slow reactions. And the ones at the bottom will not react with acids or water. So depending on the observation we see with the acids or water, we can place the elements on the basis of their reactivity and we'll get a series like this. Now there are a lot of mnemonics which are there you can use to remember the reactivity series, but most of the time they give you the reactivity series in the exam. Now, what is a displacement reaction? So we can use these reactivity series to do a displacement reaction. Now, displacement reactant is that the most reactive metal will displace the less reactive metal from its salt solution. So most reactive metals are generally found at the top and the less reactive at the bottom. So the metal at the top will be displacing the metal at the bottom from its salt solution. For example, magnesium and zinc sulfate. So magnesium is here and zinc is here. So magnesium being more reactive will displace or take the position of zinc in its compound and will form magnesium sulfate and displace the zinc. On the other hand, if we take the reaction of lead with magnesium sulfate, lead being at the bottom cannot displace the metal at the top, so no reaction takes place. So you can use the reactivity series first to predict the product of displacement, and second, whether the metal will react with hydrogen and carbon, because hydrogen and carbon are used as a reducing agents. So we can reduce the metal oxides which are lower than hydrogen for the extraction of those metals from their oxide, and the metals which are lower than carbon, for those metals we can use carbon as a reducing agent, and the metal above will be extracted by electrolysis as carbon and hydrogen cannot displace them. Okay, now let's see what is metal extraction. Now we extract metals from the minerals or the ores. Now what are minerals? Minerals are the rocks which contains the metal, and ores are those rocks are the minerals. So ores are the minerals from which we can extract the metal profitably. Now metal oxides, most of the metal exist in the form of oxide, so they can only be extracted by reducing the ore. And for reduction, I just told you we have three ways. First, by hydrogen, by carbon, or by electrolysis. All the elements which are below hydrogen can be reduced by hydrogen, which are below carbon can be reduced by carbon, and which are above hydrogen and carbon, they can only be extracted by electrolysis. For example, aluminium, and we'll be looking in this unit how do we extract aluminium. So you need to know the definition of oxidation and reduction, and there are three ways you can define them. Oxidation is gain of electron or loss of hydrogen or the oil rig. That is, oxidation is loss of electron. For example, carbon and oxygen give carbon dioxide, carbon gaining oxygen, that's an oxidation reaction. Methane plus oxygen give carbon dioxide and water. CH4 is losing hydrogen, so that's an oxidation reaction. And Cl minus converting into Cl2 plus 2 electron. As it is losing 2 electrons, it is an oxidation reaction. For reduction, it's loss of oxygen, gain of hydrogen, or gains of electron. So copper oxide plus zinc is copper and zinc oxide. So there's loss of oxygen by the copper, gain of oxygen by the zinc. H2S plus chlorine is HCl plus sulfur, loss of hydrogen by the H2S, and Na plus plus electron is Na, is a gain of electron by the sodium. Okay, so I hope this oxidation and reduction definitions is clear to you, because in the exam they can give you a reaction and they can ask you to say whether it's an oxidation and reduction. You have to look for these three cases. Okay. All right. So now, as I already told you, elements below carbon will be extracted by carbon, below hydrogen will be extracted by hydrogen, and the above by electrolysis. So copper oxide, copper is below hydrogen, we can easily reduce it with the hydrogen and can extract copper. Zinc is below carbon, so carbon can be used as a reducing agent for zinc. Okay, now let's come on to chemical reactions of acid, bases, and alkali. Now let's have a little bit key stage 3 brush up. How do we define acids? These are the substances which have pH less than 7. Bases are the substances with the pH greater than 7. Acids are strong or weak. Strong acids are those acids which are completely dissolved in water to release H+. For example, hydrochloric acid dissociates into H+ and Cl-, and we represent it with a single arrow as it is a strong acid and completely dissociated, no reverse reaction. pH is between 1 and 3. The weak acids are the ones which are partially dissociated to release H+ ions. For example, vinegar, which is CH3COOH, it gets dissociated into CH3COO- plus H+. pH is in the range of 5 and 7. Now, these are the 4 acids you need to remember for your spec with their formulas. So, hydrochloric acid is HCl, sulfuric acid is H2SO4, nitric acid is HNO3, and phosphoric acid is H3PO4. On the other hand, how do you give an example of a base? So, remember, all the metal oxides, hydroxides, and carbonates are base. So, if you remember from the periodic table unit, all the elements to the left of the periodic table are metal. So you can pick any one metal from the left side. Let's say lithium. So lithium oxide, hydroxide carbonate, sodium oxide, sodium carbonate, sodium sulfate, potassium oxide carbonate, sulfate. These are all bases. Now, there's another term that is often used for metal hydroxides, which are alkalis. Now, what are alkalis? Alkalis are nothing but the bases that can dissolve in water and make a solution. So, we can say soluble bases are alkalis and they release hydroxide ions when dissolved in water. For example, group 1 and group 2 hydroxides. Okay, now how would you distinguish between acids and bases? So to distinguish between acids and bases, we use something called the indicators. Now, indicators could be a pH meter, which will give you colors, or the pH probe, which will give you the pH reading. If the pH between 0 to 6, that is an acidic. As the pH decreases, acidity increases. As the pH increases, basicity increases. 7 is neutral, which is pure water or your salt. Second, you can have these universal indicator strips. When you dissolve it in acids and bases, they give you these range of colors and you can see it with the pH charts. If you see a color in the range of reddish orange, they are highly acidic. Greenish yellow, weak acid, green or weak base, and dark purple or blue, highly basic. Okay, now let's tabulate the difference between acids and bases. Acids have pH less than 7. They taste sour. They are not soapy. They have a pungent smell. They ionize to give hydrogen ions and they turn blue litmus red. Example, hydrochloric acid or sulfuric acid. Bases have the pH greater than 7. They taste bitter. They feel soapy. They do not have a pungent smell. They give hydroxide ions. They turn red litmus blue. Example, sodium hydroxide. Now let us look at the reactions of acids and bases. Now remember, acids and bases form salt and water, and this is a neutralization reaction, but you should know how to name the salt. Now to name the salt, each salt has two components, a metal and an acid. Now metal will be present in your base, and acid name will determine the end name of the salt. So for example, if you're using a hydrochloric acid, your salt name should end in chloride. If you're using sulfuric acid, it should end in sulfate, and nitric acid should end in nitrate. For example, sodium hydroxide is a base because sodium is a metal. So metal hydroxide is a base and a hydrochloric acid. Now it will form salt and water. So for salt and water, the rule is take the metal. So metal is sodium, and see the acid. The acid is hydrochloric acid, so it should make a chloride salt. So it's sodium, chloride, and water. Potassium oxide and sulfuric acid, metal is potassium. Sulfuric acid make a sulfate salt, so it's potassium sulfate and water. Magnesium hydroxide is magnesium nitrate plus water. Calcium carbonate is calcium sulfate plus water. Just a little thing you need to remember, if you have a carbonate, you will have an evolution of a carbon dioxide gas. Rest salt and water, the rule for salt is the same. So I hope you can now name the salt from your name of the acids and bases. Now in the exam, they can ask you to write the word equation. For the word equation, you need to look back my bonding video where I have explained you how you need to make the formulas of the ionic compounds. So sodium hydroxide is NaOH. It will react with HCl and it will give you sodium chloride and water, which is already balanced. Potassium is in group 1. Oxygen has a charge of 2. So the formula would be K2O plus sulfuric acid, and it will form potassium sulfate, which is K2SO4, because sulfate has a charge of 2 minus, potassium has plus 1 plus water. Magnesium hydroxide formula is MgOH2 plus nitric acid, HNO3. It forms magnesium nitrate, which is MgNO3 twice. Why? Because nitrate has a charge of -1, magnesium has a charge of 2 plus. So when we crisscross, we get MgNO3 twice plus 2 water molecules. And the last, calcium carbonate. Calcium carbonate is CaCO3. Sulfuric acid is H2SO4. They react to form calcium sulfate plus water plus CO2. Okay, so you should know how to write the balanced chemical equation and how to name the salts. Okay, so I hope this is clear to you. Now let's summarize reactions of the acid. If you have a metal and an acid, you don't have any oxygen in it, you get salt plus hydrogen. For example, sodium plus hydrochloric acid will make a sodium chloride plus hydrogen. Okay, so you can balance this like this. Metal oxide plus acid gives salt and water. Metal hydroxide and acid gives salt and water. Metal carbonate gives salt and water plus carbon dioxide. So everything is salt and water. Just with carbonate, you have a carbon dioxide. And if you have just a metal, there's no water, it's an hydrogen. And you need to remember the test for hydrogen, it's a squeaky pop test. Okay, now how do you make the insoluble salts? For the insolubility, you need to remember these solubility rules. All the sodium, potassium, ammonium salts are soluble. All nitrates are soluble. All chloride, bromides, and iodides are soluble except lead and silver. All the sulfates are soluble except lead, barium, and calcium sulfate. All carbonates and hydroxides are soluble except the sodium, potassium, and ammonium carbonate and hydroxides. Okay, so if you need to make an insoluble salt, you can see that the barium sulfate is insoluble. So you can basically take barium hydroxide and sulfuric acid and form barium sulfate. So you mix two soluble acids and bases. The salt will come out as a precipitate as it is insoluble. You filter the solution. The salt will stick to the filter paper, and you can dry the filter paper and get the salt. So this is a way how you make the insoluble salt. Now, how will you determine what is the exact quantity of acid and base you use? You do titrations. And how you do titrations? You need to check the C4 video, which is on quantitative chemistry. There I have explained the whole process of titration. To make the soluble salts, you make insoluble base into the aqueous solution of the acid until all the base dissolve. When the base do not dissolve, you stop there. You filter the solution to remove excess undissolved base. The runoff will be your salt with water. Then you crystallize that solution. All the water will evaporate and the crystals of your salt will be left. Or you can determine the exact quantities of acids and base by a titration setup. You will get salt and you can do crystallization to get the soluble salts. You must have done copper sulfate crystals. This is how it works. Okay, so now let's come to the last part, which is electrolysis. Now, electrolysis consists of two words. Electro means electricity, lysis is breaking. So when you have breaking of an ionic compound in presence of electricity, that is electrolysis. Now, electrolysis setup is you take a container where you have an electrolyte. Electrolyte is a substance that undergoes electrolysis. When an electricity is passed through it, it breaks into constituent ions, which will be either positive and negative. The positive will go towards the negative electrode. The negative electrode is a cathode, where cations or the positive charge ions go, and anion is the positive electrode where the negative charge ions go. And these electrodes are the two conducting rod. Now, what happens at the cathode? Cathode is rich in electron, so the cation will gain an electron, and at anode, the anions will lose an electron. Let's see with an example. So, for example, I have taken molten sodium chloride. Now, sodium chloride will dissociate into Na plus and Cl minus. Na plus, being a cation, will go towards the cathode, and Cl minus, being an anion, will go towards an anode. Okay. Now, what will happen at a cathode? The sodium, which is the positive, will gain an electron because the cathode is the negatively charged electrode, will gain an electron and converts into sodium solid. So you can see here, at the cathode, which is the negative electrode, sodium goes in, gains an electron and converts sodium solid that start to deposit. At the anode, which is the positive charge, Cl minus will lose an electron, converts into chlorine, which is a greenish yellow. Chlorine gas will escape. Okay. Now remember, this is a molten sodium chloride. Molten sodium chloride means in this there's no solution, that is, it just has sodium and chloride ions. Now you remember from the bonding topic, ionic compounds conduct electricity when in molten or in solution. As in molten or the solution phase, the ions are free to move. Okay. Now let's see if this would have been a solution, what would have changed? Now, sodium chloride solution means it has sodium and chloride ions, plus water is also present, and water also dissociate into H plus and the OH minus ions. Now, at the cathode, both the hydrogens and sodium will be competing to gain electron, and at the anode, both OH minus and Cl minus will go to lose an electron. But who will win? For that, we have this rule. At cathode, the element with the least reactivity will get discharged and gains an electron. And for that, you look at the reactivity series. Now, if you look at your reactivity series, you will see hydrogen is at a lower level than sodium. So, hydrogen will gain an electron and converts into a hydrogen gas. And at cathode, you will see an evolution of hydrogen gas. At the anode, the rule says always the halide ion loses an electron, followed by the hydroxide ions and any other negative ions after that. So you need to remember this rule. So here we have an halide ion, so Cl minus will convert into chlorine plus 2 electron. So we are left in the remaining solution Na and OH minus, which did not win and remain in the solution. Let's take another example. To make sure if you remember the rule, you take potassium sulfate. Now, potassium sulfate will dissociate into K plus plus SO4 minus ions. To remember these charges, go to my bonding video. I have given you the table on how to remember the charges. And it is a solution. Remember, for any electrolysis, you need to look at word molten or solution. If there's a solution, you need to follow this rule, and water is there in that. So solution have H plus and OH minus. Now we look at the periodic reactivity series for K plus and H plus, and we'll see H plus is lower in the reactivity series. So H plus will gain an electron and form hydrogen. For SO42 minus, OH minus, we see this rule. It's not a halide. So OH minus will lose an electron, and you need to remember this half equation for hydroxide ion. OH minus changes into oxygen, water, and 4 electron. So in the remaining solution, we have potassium sulfate left. So potassium sulfate did not get electrolyzed. It's just the water that gets electrolyzed. Okay, so I hope this rule is clear to you, and you can yourself see the difference. When you had a molten sodium chloride, you get sodium and chlorine. But when you have an aqueous sodium chloride solution, you get hydrogen and chlorine. Okay, so I hope the rule and how do you find in an exam what will be the product of electrolysis is crystal clear to you. Okay, now next we have electrolysis of aluminium oxide. Now when we looked at the reactivity series, I hope you remember the element above carbon and hydrogen do not have any reducing agent. They can only be reduced by electrolysis. So that's what we do for aluminium oxide. Aluminium oxide is an ore. The ore is in bauxite. It dissociates into Al3 plus and O2 minus ion. For bauxite, you need to remember it has a very high melting point, and giving such a high temperature will be very difficult, because to undergo electrolysis, we need to melt bauxite. So what do? We mix it with another ore of aluminium, which is cryolite. When aluminium oxide is mixed with cryolite, it lowers the melting point, so it melts at a lower temperature. So you get the molten aluminium oxide as a lower temperature. Now this is the setup of the electrolysis. The carbon lining is the negative electrode where the Al plus goes, gain electron and converts into aluminium solid. But at such a high temperature, the liquid aluminium is formed and you taper it off. The graphite electrodes are the positive electrode where O2 minus goes, and then it loses an electron and form oxygen gas. This oxygen gas reacts with these graphite electrodes and convert into carbon dioxide and is involved in the atmosphere. So this is the reaction which results in the consumption of these graphite electrode. So these graphite electrodes are used in the reaction, therefore they are used up and needs regular replacing. Okay, so in aluminium oxide, you need to remember the role of cryolite, these half equation, where is aluminium collected and why you need to replace the graphite electrode. Okay, so I hope this is clear to you. Now let us look at the key terms. So this is the time to test yourself. Pause the video and write these key terms that we have discussed in this video. So we have seen what are acids, bases, metals, reactivity series, reduction, oxidation, alkali, salt, neutralization reaction, indicators, pH scale, soluble salts, insoluble salts, electrolysis, electrodes, anode, cathode, electrolyte, ionic compounds, cryolite, bauxite, ore and metal extraction. Pause this video, have a go at these answers, and I hope you should be able to answer all of them. Okay, so as for my always advice, what's the next step? Check this specification, make sure everything is there. We classify the reactions into two categories, exothermic and endothermic. Now, these two reactions are based on the law that energy is neither created nor destroyed. It is transformed to one form to the another. Now, there are certain reactions which will take in heat and the certain reactions which will release heat to the surrounding. Now, exo means external. So, any reaction that releases heat external, so that releases the heat to the surroundings, are the exothermic reactions. And endothermic, endo means inside. So, any reaction that takes in heat from the surroundings are endothermic reaction. Now, naturally, if any reaction is releasing heat, it will make the temperature increase of the surrounding. So the exothermic reactions are accompanied by increase in temperature of the surroundings as the heat is released. On the other hand, the endothermic reactions are accompanied by decrease in temperature of the surrounding as the heat is absorbed. Now, in exothermic reaction, as you're releasing heat to the surroundings, so naturally the product energy will come down. So the product have lower energy than the reactants in an exothermic reaction, and in an endothermic reaction, the product has a higher energy than that of the reactants. Now, example of an exothermic reaction, combustion and respiration. Example of an endothermic reaction, that is thermal decomposition and photosynthesis. Now we can also define exothermic and endothermic in terms of bond breaking. Now in terms of bond breaking, the exothermic reactions are releasing more heat, and whenever the heat is released when the product is made, and whenever the heat is taken in when the reactants are broken down. So every reaction, in order to break the bonds, it takes in heat, and whenever it makes the bond, it will release heat. Now in an exothermic reaction, as the heat released is more, it means that the product is giving more energy, then it is used up in breaking the reactants. And the endothermic reaction, in terms of bond breaking, the bonds of the reactants are taking in more heat to break the bonds, rather than, which is more than the energy released in making the products. I hope this concept is clear to you. If not, do not worry. After a couple of slides, we'll again go over this. Now, you know exothermic reaction releases heat to the surroundings. So as exothermic reactions are releasing heat to the surroundings, they are used in the self-heating cans and the hand warmers, whereas the endothermic reactions are used in ice pack for the sports injuries. Okay, so I hope this difference is clear to you. Now let us look at the reaction profile diagram. It can come in the exam to draw them or to label the reaction profile diagram. Now, for both of these reactions, you will be making the axes. The y-axis will be labeled as energy. The x-axis as progressive reaction. You will do both sides. You will make a line of the energy of the reactants on both sides. On the exothermic, the product has lower energy, so place product as a lower energy level than the reactants. In endothermic, the product has higher energy than the reactants. Now join the reactants and products with the bump at the top. Same to the other side. This bump, which is the energy of the reactant, still the highest point is the activation energy. You should remember it. This is the minimum energy that every reactant should have to start the reaction. And the difference in the energy of the reactants and product is the heat released or absorbed. In case of exothermic reaction, the difference in the energy of the reactants and product is the energy released to the surrounding. And in case of an endothermic reaction, this difference is the energy absorbed from the surrounding. Okay, so I hope this is clear to you. Now let me again explain you the concept of bond making and breaking. In every reaction, there's a reactants which is converting into a product. The reactants are breaking the bonds, and that is taking in heat. The products are making the bond, and that is always releasing the heat. Now in an endothermic reaction which takes in heat, the breaking of the bonds takes in more heat, then it is released in the products when the heat is made. In an exothermic reaction, breaking of the bonds of the reaction takes in heat is less than the making of the bonds of the product that releases heat. Okay, so this is how you can define the reactants and products in terms of bond breaking. It has come up in the exam to write this definition in terms of bond making and bond breaking. So you should explain this definition in that. Okay, next is the bond energy calculation. This is a higher tier question where you need to first display the bonds of the reactions and the products from the data booklet, take the bond values, add the bond values of the reactant side, add the bond values of the product side, take the difference of the two, and that will give you the heat associated with the reaction. So here we have AA bond and BB bond. From the data booklet, we have 221 and 325. That gives you 546. For the two AB, it's 2 times the AB bond. So 2 times the AB bond, which is 425. That gives 850. So the energy required to break the bonds of the reactants is 546. The energy released to make the products is 850. You take away the 2. That gives you minus 304. So 304 is the energy released to the surrounding. And in this case, the product is having the higher energy, is releasing more energy than it is used up in the reactants. So therefore, it's an exothermic reaction. Okay, so I hope this bond energy calculation is clear to you. Now, what is cell and a battery? A cell is a device that converts a chemical energy into electrical energy. In a simple cell apparatus, you can see to the left side, we have two metals, zinc and copper. They both are dipped into the solution of the electrolyte, zinc sulfate and copper sulfate. The more reactive metal will send the electron to the less reactive metal, and this movement of electron will generate electricity as it constitutes the electric current. Okay, so this is how we do the cells and the battery. Now, this is what you have in your syllabus, a fuel cell. A fuel cell is a device which again converts the chemical energy into electrical energy, but that relies on the reaction of hydrogen and oxygen to form water. So this is a setup of a fuel cell. The hydrogen is pumped at the negative electrode and it provides the electron. Oxygen is supplied to the positive electrode, which forms hydroxide ions. Now the equation is at the negative electrode, hydrogen and hydroxide combines to form water and electron, and at the positive electrode, oxygen takes up water and these electrons to form 4OH minus. So hydrogen is donating the electrons to the oxygen side. This movement of electron generates electricity, and overall this reaction results in the formation of water. So hydrogen and oxygen forms water. So what is the good part of this reaction? No harmful gases are released. The only product formed is water, which is not a harmful or a toxic product. No harmful gas or waste is produced. Waste product is only water, so no problem to the environment, and it do not need recharging. On the other hand, there are still disadvantages of a fuel cell. Hydrogen is flammable. Production of hydrogen depends on non-renewable resources. Hydrogen gas, being a gas, is difficult to store and transport, and storing and transport of hydrogen involves energy which comes from fossil fuel. Thereby, it does contribute to global warming. Okay, so I hope this topic is a short, sweet, and simple topic. Let us just quickly look over the key terms that we saw in this topic. What is an exothermic reaction? The reaction which gives out heat. Example, respiration and combustion. Endothermic reaction are the reaction which takes in heat from the surrounding. Example, photosynthesis or thermal decomposition. Reaction profile is a diagrammatic representation showing the relative energies of reactants and products in a reaction. Activation energy is the minimum energy required to start the reaction. Bond energy is the heat energy contained in a bond between two atoms. Chemical cell is a device that converts chemical energy into electrical energy. Fuel cell is a chemical cell that uses a reaction between hydrogen and oxygen to form water and energy and generate electricity. Batteries are the collections of cells. Okay, so I hope these key terms are clear to you. Now let's test yourself. You can pause this video, have a go over these questions, and come back to check the answers. So you need to label this reaction profile and label it if it is an exothermic and an endothermic. You have to draw an energy profile diagram of an endothermic reaction, give two applications of exothermic and endothermic reaction, and state the advantages and disadvantages of a fuel cell. Pause the video, have a go at these answers. Okay, so now let's look at the answer. To label it, you will be labeling the axes. This is energy, this is progress of reaction, this is the energy of the reactants, this is the energy of the products. The reactants gives a bump, and that's the activation energy. And this difference between the reactants and the products is the energy released to the surrounding. And in this reaction, the product has a lower energy than the reactant, therefore it's an exothermic reaction. This is an energy profile diagram of an endothermic. So it's an energy progressive reaction. The products at the high energy level, then the reactants, and then we have the activation energy pump. The application of an exothermic reaction is the self-heating cans and hand warmers. For the endothermic, it's the ice pack and the self-cooling cans. For the advantages and disadvantages of the fuel cell, we have already discussed. No waste product. Waste product is only water, does not need charging. Disadvantages: hydrogen is flammable. Production of hydrogen depends on non-renewable resources. Hydrogen, being gas, is difficult to store and transport. And storing and transport of hydrogen again involves a dependency on fossil fuel, which contributes to global warming. Okay, so I hope this topic is clear to you. Now the next step is to check the specification. Make sure everything which is there in your specification should be crystal clear to you. And you need to do the exam questions on this topic, which is very, very important. You can get them on my website. Okay, so I hope you like this video. If you like this video, then please do like, comment, and share this video amongst your friends. Please spread this word around. Make sure that every person who needs this video gets the chance to see this video. And if there's any video which you want me to make before your exam, just leave a comment below and I'll try to make it. I'll try my level best to have that uploaded before your exam. If you still have any doubts in any of this topic, then you can leave a comment below. We'll reply you quickly. Or you can come to our website. There we have set up a 24/7 chat support till your exams, where you can post any of your queries and get instant reply. Okay, so do not forget to leave a comment below to tell me the topic on which you want me to make the next video. Till then, happy revising.